Good evening students, welcome to my YouTube channel. Today we will cover the remaining topics of your gravitation chapter. Some important topics were left, and in this session we will cover these important topics. Already most of the topics were covered, like Kepler's law of planetary motion, free fall concept, what is gravitation, the law of gravitation. Some important topics were already covered and some numericals also, and today we will cover the remaining topics, and we'll start with the concept that is pressure in fluids. Pressure in fluids. Now what is fluid? What is fluid? We should know that what do you mean by fluids. Now fluids are actually called liquid and gases, because liquids can flow and gases also can flow. That's why liquids and gases both are termed as fluids. Liquids and gases. Fluids are liquids and gases. Liquids and gases together called as fluids. Now we know that there is a three states of matter. One is solid, one is liquid, and another one is gases. Now solids exert pressure on the surface. We know that solids exert pressure on the surface due to their weight, or due to its weight. Now like solids, liquids and gases also exert pressure, and the reason is that they exert pressure due to its weight. Due to the weight of fluid, it also exerts pressure like solids. When any fluid is put in a container, they also exert pressure on the base of the container and wall of the container, and the pressure is given by fluid. It exerts in all directions. That means, suppose you have a container. This is the container, and you have placed a fluid in this container. Now what happens is that when you placed a fluid in this container, the fluid will exert pressure on the base of the container. This is the base of the container, and this is the wall of the container. So whenever you put any fluid in this container, the fluid will exert pressure on the base of the container and the wall of this container due to the weight of the fluid. So reason is that the weight of the fluid exert pressure due to its weight, and the pressure is in all directions. The fluid exert pressure in all directions. Clear? So that is the pressure of fluid. So related to this pressure of fluid, next concept is your buoyancy. Buoyancy. What is buoyancy? Now suppose you have a container. And a fluid or any liquid is immersed in it. Any liquid or fluid is immersed in it. This is the fluid level. Clear? And you have immersed a fluid. You have, the container is contained with a fluid. Now buoyancy is a phenomenon. Now whenever you are immersing any object, suppose you are immersing any solid object. Suppose this is a solid object. Whenever you want to immerse a solid object in this fluid, the fluid will gives an upward force. This upward force is known as upthrust or buoyant force. Listen very carefully. We have a liquid, any liquid or any fluid in this container. Whenever you want to immerse any solid object in this fluid, the fluid will gives you an upward force, or it is known as upthrust or buoyant force. And this phenomenon or this tendency of a liquid to give an upward force or to exert an upward force when any object is immersed in a liquid is called this buoyancy. Clear? Whenever any solid object, you want to immerse this solid object in this liquid, the fluid will exert an upward force. That means it will prevent from immersing the object. That force is known as upthrust or buoyant force, and the tendency of that liquid will be known as buoyancy. Clear? This is the general concept of any fluid. Clear? So just write the concept that the tendency the tendency of a liquid to exert the tendency of a liquid to exert an upward force, the tendency of a liquid to exert an upward force on an object immersed in it or in a liquid is called buoyancy. Clear? This is the property of fluid, and this buoyancy property, it is showed by both liquid and gases. This buoyancy property is showed by both liquid and gases. So the tendency of a liquid to exert an upward force on an object immersed in it is called buoyancy. Clear? And what is buoyant force? Buoyant force is the upward force. Buoyant force is the upward force given by the liquid. That is the buoyant force, and it has another name, buoyant force or upthrust. So the upward force exerted by the liquid, that is your buoyant force. Clear? So just write buoyant force, buoyant force, or it is also known as upthrust. Buoyant force or upthrust is an upward force. Buoyant force or upthrust is an upward force which acts on an object, when it is immersed in a liquid. That is the buoyant force or upthrust force. It is an upward force. Whenever any object is immersed in a liquid, then the liquid will also gives the object an upward force or upthrust, that is known as buoyant force. That means the liquid tends to prevent the object from immersing. Any liquid or any fluid will tend to prevent the object from immersing in the liquid, that is by giving an upward force or by giving an upthrust. That is the buoyant force. Clear? Or the tendency is known as buoyancy. It is a property given by liquids and gases also. That means it is a property showed by fluid, and fluids are liquids and gases together, they are called fluids. So buoyancy property showed by liquids and gases together. Next, this is the main reason, this buoyant force or buoyancy is the main reason due to which a heavy object seems to be lighter in water. Whenever you immerse a heavy object in water, the heavy object seems to be lighter in water. Why? Because due to the presence of this buoyant force. So make a note here, like it is the buoyant force, due to which a heavy object seems lighter in water. This is the reason, that is the buoyant force is the reason due to which a heavy object seems to be lighter in water. Clear? So this is all about buoyant force and the property buoyancy, the property of fluids. Now what are the factors that affect this buoyant force? What are the factors that affect this buoyant force? So factors affecting buoyant force. What are the factors affecting buoyant force? Number one factor, there are two factors. Number one factor is the density of the fluid, that is the number one factor, that is density of the fluid. Number two factor is the volume of the object immersed in the liquid. Volume of the object immersed in the liquid. These are the two factors. Number one factor is the density of the fluid, and number two is the volume of the object immersed in the liquid. That is the two factors on which the buoyant force depends. So talking about the first factor, that is the density of the fluid. Now always remember, the liquid having higher density exerts more upward buoyant force on the object than the liquid of lower density. That means if a liquid have higher density, they exert more upward buoyant force than the liquid of lower density. That is the reason why it is easier to swim in sea water in comparison to normal water. Question is asked that why swimming is very easier in sea water compared to normal water. The answer is, in sea water the density is much high. In sea water density is much high in comparison to normal water. That's why it is easier to swim in sea water. Clear? Sometimes this question can be asked in your exam. The question will be like this: tell the reason or state the reason why it is easier to swim in sea water. Your answer will be, the density of sea water is much high than compared to the normal water. That's why it is easier to swim in sea water. Clear? Also, this is the general reason. The second reason will be, the liquid, we know the liquid of having higher density will exert more upward buoyant force. So in sea water, the density of sea water is much high, so the sea water will exert more upward buoyant force, and so we can swim very easily. So this would be the answer. Clear? So always remember, density of fluid will proportional to the upthrust or buoyant force. That means higher the density of the fluid, higher the upthrust or buoyant force. Lower the density of the fluid, lower will be the buoyant or upthrust. Clear? So if you take the fluid of higher density, the upthrust will be more, and if you take the fluid of density of lower density, the upthrust will be low. So that is the factor affecting buoyant force. So first property is density of the fluid. If you take the fluid with high density, your upthrust or buoyant force will be more, and if you take the density of fluid with low density of fluid, your upthrust or buoyant force will be low. Clear? So just write a question here from this factor. Question will be asked that why it is easier to swim in sea water than normal water. Just write this question. Question is, why it is easier to swim in sea water than normal water. Write the answer. Write the answer. That just write. I am dictating and just copy my word. The answer is, it is easier to swim in sea water in comparison to normal water. It is easier to swim in sea water. It is easier to swim in sea water compared to normal water, because it is easier to swim in sea water compared to normal water, because sea water has higher density. Because sea water has higher density. And hence, because sea water has higher density and hence exerts a greater buoyant force on the swimmer, and hence exerts a greater buoyant force on the swimmer than the normal water having lower density. Clear? So this question can be asked in your exam. This question is related to the first factor, that is density of the fluid. Coming to the second factor, that is volume of the object immersed in the liquid. Now whenever you immerse any object on the liquid, its volume is dependent on the buoyant force. How it is dependent? The volume of the solid immersed inside the liquid, if increases, the upward buoyant force also increases. That means volume of object immersed in a liquid also directly proportional to upthrust or buoyant force. That means if the volume of the object immersed in a liquid increases, the upward buoyant force or upthrust also increases. Clear? If the volume of the solid of the object inside a liquid increases, the upward buoyant force also increases. The magnitude of this buoyant force acting on that object does not depend on the nature of the object. It only depends on the volume. Always remember, the volume of the object inside the liquid, if it increases, the upward buoyant force or upthrust also increases. That is the relation between the volume of the object immersed in a liquid and the buoyant force. Now this buoyant force or the value of this buoyant force or magnitude of this buoyant force, it does not depend on the nature of the object. That means what object you are immersing, the nature of the object. The buoyant force does not depend on the nature of the solid object. It only depends on the volume of the object. What is the volume of the object? If volume increases, then upward buoyant force also increase. Clear? Now this is the reason. The example is that when two balls made of different metals, when two balls, suppose we have two balls, one ball is A and one ball is B. You have two balls, one ball is A and one ball is B. The two ball made of different metal. These two balls are made of different metal. This ball is made, suppose it is made of iron, and this metal is made of, suppose, copper. These two balls are made of different metals having different weights. They have been made of different metals, and also they have different weights but equal volume. This ball is made of iron and this ball is made of copper. So these two balls are made of different metals. They have different weights but equal volume. When these two balls immersed in a liquid, the two balls will experience same amount of upward force or same amount of upthrust because the volume is same. That's why when these two balls, when immersed in a liquid, the two balls will feel exactly the same upward force or same buoyant force due to the equal volume. That means it is made of iron, it is made of copper. The two balls have different weight but equal volume. So when these two balls immersed in a liquid, they experience an equal upward force or equal buoyant force because both these balls will displace equal amount of liquid. That means they have equal volume. That's why they will displace equal volume of liquid. When they immerse in a liquid, the two balls will displace equal amount of liquid because volumes are same. That's why they will experience a same or equal upthrust or buoyant force. Clear? So this is the example. So these are the two factors that depends on the buoyant force. These are the factors. One is density of the fluid and one is volume of the object immersed in the liquid. Next concept is floating or sinking. Floating or sinking of an object. When object will float and when object will sink. Suppose you have a container. This is the container, and you have this container is filled with a liquid or fluid, any liquid or fluid, and this is the object immersed in the liquid. This is a solid object. That is the upthrust and that is the weight of the object. We know that a fluid or liquid exert pressure due to its weight. Clear? Now when an object is immersed in a liquid, the two forces acts on the object. Suppose this is the object, it immersed in a liquid. So two forces will act whenever an object is immersed in a liquid. Number one force is weight and number two force is upthrust or buoyant force. So it is upthrust or buoyant force. So when an object is immersed in a liquid, two forces will act. The number one force is its weight, due to which the object will exert pressure, and second one is upthrust or buoyant force. So number 1 is weight and number 2 is upthrust or buoyant force. Whenever any object is immersed in a liquid, the two forces will act. One is weight and one is buoyant force. The weight will act in downward direction. That is the weight. See, this object is immersed in this liquid and the weight is acting in the downward direction. The weight will act in downward direction. That is, it tends to pull down the object. The weight of the object will tends to pull down the object in the liquid. That is the force number 1. The second force will be upthrust force or buoyant force, which acts in the upward direction. It will act in the upward direction. That is this is the direction, that is upward direction, and it tends to push up the object from the liquid. So there is two force, one is weight and one is upthrust. Whenever an object is immersed in a liquid, the weight will act in the downward direction, that is it tends to pull down the object in the liquid, and second one is buoyant force or upthrust. This is the upward direction. This force acts in upward direction and it tends to push up the object from the liquid. Clear? Now whether an object will float or sink in a liquid, it depends on the relative magnitude of these forces. Whether an object will float or sink in a liquid depends on the relative magnitude of these two forces. And these two forces are acting in opposite direction, because weight is acting in the downward direction and upthrust is acting on the upward direction. That means these two forces are acting in opposite directions. So there are three conditions for floating and sinking of this object. Total three conditions are there. There are three conditions for the floating or sinking of this object. Listen very carefully, this is an important concept. There are three conditions on which the floating and sinking of object depends. And the floating and sinking, the object whether will float or sink in a liquid, depends on the relative magnitude of these two forces, that means weight and upthrust. Now if the buoyant force or upthrust exerted by the liquid is less than weight, that means upthrust is less than weight, upthrust or buoyant force is less than weight, then the object will sink in the liquid. If this condition prevails, that means when upthrust or buoyant force exerted by the liquid is less than weight of the liquid, is less than weight of the solid. I am repeating again, when upthrust or buoyant force exerted by the liquid is less than the weight of the object will sink in the liquid. In this condition, the object will sink. This is the first condition. The second condition is that when the buoyant force or upthrust is equal to the weight, this upthrust or buoyant force is equal to the weight, the object will float in the liquid. It will float. In this condition, it will float in the liquid. That means when upthrust force or buoyant force given by the liquid is equal to the weight of the object will float on the liquid. Third condition is that when upthrust or buoyant force is more than weight, that means when upthrust or buoyant force is more than weight of the object. In this condition, the object will first rise in the liquid and then float. In this condition, the object will rise in the liquid. The object will first rise in the liquid and then float. That is the condition. The three conditions. There are three conditions. When upthrust is less than weight, that is upthrust or buoyant force exerted by the liquid is less than the weight of the object will sink. When both the forces are equal, that is upthrust or buoyant force given by the liquid is equal to the weight of the object, then the object will float. And when upthrust or buoyant force given by the liquid is more than the weight of the object, then the object will rise first and then it will float. So three conditions are there for floating or sinking of any object. Clear? This is the important concept. Just learn very carefully. Next, density of the liquid. What is the density of the liquid? What is the density of liquid? Now density means mass per unit volume. density of a substance or density of a liquid means mass per volume. It is represented as rho. This symbol is known as rho. Density of a liquid is given by rho. So rho equals to m by v, that is mass by volume. That means mass of the substance divided by volume of the substance. So density means mass of the substance divided by volume of the substance. Rho equals to m by v, that is your density. It is defined as mass per unit volume. Mass per unit volume, that is the density. What is its unit? What is the unit? SI unit of density is kilogram per meter cube, that is kg/meter to the power 3, or you can also write kg meter to the power -3. This is the SI unit of density. Its CGS unit is gram centimeter to the power 3, or you can write gram centimeter to the power -3. That is the SI unit of density. It is also, remember, it is also a scalar quantity. It is a scalar quantity. It is a scalar quantity because density has value only. It has no direction. That's why it is a scalar quantity. Clear? So it is also a scalar quantity. That is the density of liquid. Clear? Now write a small numerical that is based on the density concept. Suppose you have told that a sealed can having mass of 700 gram. A sealed can has mass of 700 gram and volume equal to 500 centimeter 3. A sealed can has mass 700 gram and volume 500 centimeter to the power 3. Will this can sink in water? Will this can sink in water? This is the question. Will this can sink in water? That is the question. Now whenever this type of question is asked, whenever in your exam this type of question is asked, just find first the density of the can. That means the solid object is can. Here the solid object is can, and the can whether it will sink in water or float in water, you have to find out. So here can is the solid object. You are immersing the can in water. That means just find the density of the can first. And if the density of the can is greater than the density of water, then the can will sink. And if the density of the can is lower than the density of water, then the can will float. So it's very simple. So just find the first density of the can. So mass is given. Mass of the can is given. Mass small m given. That is 700 gram. Volume small v, it is given 500 centimeter to the power 3. So volume and mass is given. So just find density of the can. So density of can, density is represented by rho, and rho means m by v. So m is given 700 gram and volume is given 500 centimeter to the power 3. So 0 will eliminate. 7 by 5 gram centimeter to the power 3. This is C, gram centimeter to the power 3. So 7 by 5 means 1.4 gram centimeter to the power 3. See, density of the can is 1.4 gram per centimeter to the power 3. And what is the density of water? Always remember, density of water is 1 gram centimeter to the power 3. Just remember the value of density of water. This is the density of water. It is not given in the question. Clear? You have to remember this value. That is, density of water is 1 gram per centimeter to the power 3. Now see, density of can is greater than the density of water. So it will sink in the water. If the density of the can is less than water, then only it will float. But the density of the can is greater than the density of water. So the can will sink in the water. Therefore you will write, therefore can will sink in water. What is the reason of sinking? The reason is density of can is greater than the density of water. That's why the can will not float. It will sink in water. Clear? So this type of question can be asked in your exam. This is a small numerical question. This type of question can be asked in your exam. Clear? And this is the way you will solve this type of questions. Next, very important topic is Archimedes principle. Based on density, and floating and buoyant force, all that concept we have still discussed. The next very important principle, that is Archimedes principle. Archimedes principle. What is Archimedes principle? Now Archimedes is a scientist, and he proposed a principle based on the flotation sinking property. He states that when an object is fully or partially immersed in a liquid, listen very carefully, when an object is fully or partially immersed in a liquid, it experiences a buoyant force or upthrust. When an object is fully or partially immersed in a liquid, it experiences a buoyant force or upthrust, which is equal to the weight of the liquid displaced by the object. So let me first write the principle, then I will discuss elaborately. He states that when an object is fully or partially, when an object is fully or partially immersed in a liquid, when an object is fully or partially immersed in a liquid, it experiences a buoyant force or upthrust, which is equal to the weight of liquid displaced by the object. That is the principle proposed by him. So when an object is fully or partially immersed in a liquid, it experiences a buoyant force. This is a very clear concept, because in previous we have discussed that whenever you immerse any solid object in a liquid, whether partially or fully, it will the liquid will provides you a upthrust or upward force, that is known as buoyant force. So when an object is partially or fully immersed in a liquid, it experiences, that means the object experiences a upward force or buoyant force, which is equal to the weight of the liquid displaced by the object. That means the buoyant force or upthrust will be equal to the weight of the liquid displaced by the object. So in a straight cut way, we can write that buoyant force or upthrust acting on an object, this will be equal to the weight of liquid displaced by the object. Weight of liquid displaced by the object. Whenever any object is immersed in a liquid, the object will displace some liquid. Whenever, suppose this is the jar, and the liquid is poured in the jar, and you are trying to immerse this object. Now whenever you try to immerse this object, the object will displace some liquid. It will displace some liquid. Clear? Whenever you want to immerse this object, the object will displace some liquid. Clear? And the weight of this liquid displaced by the object is equal to the buoyant force. I am repeating again. Suppose this is the container or pot, and some fluid is poured in this pot, and you are trying to immerse this object. So whenever you are trying to immerse this object in the liquid, the object will displace some water or some liquid, and the weight of that liquid, that means weight of the displaced liquid, will be equal to the buoyant force or upthrust. Clear? That is the principle given by Archimedes. So buoyant force or upthrust acting on an object will be equal to the weight of the liquid displaced by the object. When you are trying to immerse any solid object, the solid object will immerse, the solid object will displace some liquid, and the weight of that liquid, that means weight of that displaced liquid displaced by the object, will be equal to the buoyant force or upthrust. That is the principle of Archimedes. Clear? Now the question is asked that where this Archimedes principle are used. What are the applications? What are the applications of this Archimedes principle? What are the applications of this Archimedes principle? So first application, number one application is this principle is used for designing ships and submarines or warships. This principle is used for designing the ships and warships and submarines. So just write first applications is designing ships and submarines. Designing ships and submarines. This is the first application. Second application is lactometer. Lactometer means a device which is used to determine the purity of milk. Lactometer. It is a device. Lactometer is a device which is used to determine the purity of milk. That means how the milk is pure. The milk is pure or not. The purity level. The milk is pure or not. He will determine by the use of this device. That device is known as lactometer. It is used for determining the purity of milk. So this is the application of Archimedes principle. The third and last application is the hydrometer. Last and third application is hydrometer. What is hydrometer? Hydrometer also is a device. It is determined. It is used for determining the density of the liquid. The density of a liquid. Any liquid, you can use this device to find the density of that liquid. So hydrometer is a device which is used to find or to determine the density of the liquid. So these three are the applications of this Archimedes principle. Here Archimedes principle is used. Clear? Now last topic of this session. So just very carefully just study this Archimedes principle, because this is the important concept of this gravitation chapter. Last concept is that relative density. Relative density. What is the relative density? Now relative density of any substance is the ratio of its density to the water. Remember, relative density is just a ratio. Relative density is just a ratio, the ratio of the density of the substance and the density of water. Suppose you want to measure the relative density of iron. So what will you do? You will just compare the density of iron to the density of water. Clear? That means the relative density of the substance is equal to the density of the substance divided by density of water. That means you will just compare. You will just compare the density of the substance with the density of water. That is your relative density. Relative means comparing. Here you will compare the relative density with water. So relative density, this is equal to density of substance divided by density of water. That is the relative density. Clear? Or also you can write, now we know that density rho means, density is rho, density rho means m by v, that is mass by volume. This is the density. Density is represented by rho. So density means mass by volume. So also you can replace the density here. That means you can write mass of substance divided by volume of substance divided by mass of water divided by volume of water. Because density of substance, now density means mass by volume, so mass of substance divided by volume of substance. Density of water, density means mass by volume, see mass by volume, so density of water means mass of water divided by volume of water. Now just rearrange, so mass of substance divided by volume of substance into, it will just reciprocate, that is volume of water divided by mass of water. That is the relative density. It is just a ratio. Relative density is just a ratio of similar quantity. Similar quantity means this is also the density, quantity 1, and this quantity 2, this is also density. So relative density is just a ratio, and hence it has no unit. Always remember, relative density has no unit. Relative density has no unit because it is just the ratio of similar quantity. This is the density and this is also density. So two quantities, there is two quantity, two similar quantity, and two quantities are density. So it has no unit. It is a ratio of two similar quantity. That's why relative density has no unit. Clear? So that is the concept of relative density. Clear? So that's it. This is the last topic that were yet to be discussed, the relative density. So all the concept, all the topics under this gravitation chapter were complete, and I hope you enjoyed the session. In the next part, we will provide the numerical questions related to this chapter. Clear? So thanks and have a nice day.